Hello, everyone. I'm Rebecca Bickham, editor of AMP's Materials Performance magazine. Today, we're joined by Dr. David Norfleet, head of the Laboratories and Testing Department at DNV Energy Systems. Thank you so much for joining us today, David.
Thank you so much. Happy to be here.
My pleasure. So, David, first of all, for those who may be unfamiliar with DNV, what can you tell us about the company?
Sure. DNV was established in 1864, and we're an independent expert in assurance and risk management services. We provide our customers with facts and reliable insights so that they can make critical decisions with confidence. DNV currently operates in over 100 different countries. We have approximately 12,000 employees globally, and we offer advisory and laboratory research and testing services for a variety of different industries, including the energy sector.
There are some exciting emerging trends and technologies right now, especially related to hydrogen. So why is hydrogen an attractive fuel option for energy storage and transportation?
Well, when hydrogen burns or combusts, it breaks down to form heat and water. So hydrogen offers an opportunity to decarbonize our existing energy systems to help achieve targets set forth by the Paris Agreement. DNV is anticipating that hydrogen will satisfy approximately 5% of the total energy demand by 2050. Given that there's very little utilization currently for hydrogen, this constitutes a significant growth area for the energy industry. This isn't without inherent challenges. First and foremost is that the energy industry must better understand how hydrogen affects current pipeline infrastructure.
What should pipeline operators take into consideration when utilizing existing infrastructure for a decarbonization strategy?
Yeah, Rebecca, there's an awful lot for the operators to consider. First is that the materials, the methods, and the practices that were used to fabricate transmission and distribution pipeline networks have matured over the last decade. Each asset is unique in this regard, such that feasibility studies should be performed on each individual asset to better determine the suitability for transferring the service of a given asset to a new operating environment, which may be hydrogen blends, ammonia, or CO2 for carbon capture and storage applications. Complicating these feasibility studies is that each pipeline is comprised of a variety of pipeline materials and component materials, welding and construction practices, and in some instances, variations in the historic operating conditions of that given asset. As a result, there's a need for specialized testing in these environments to evaluate the compatibility, the performance, and the safety of these materials in their given environments.
David, what can you tell us about DNV's Materials Performance and Testing Laboratory in Columbus, Ohio?
The Materials Performance and Testing Laboratory in Columbus is part of DNV's global network of technology centers that conduct failure investigations and a variety of tests and experiments in challenging operating environments. These tests can include full-scale test setups to represent pipeline segments, down to small-scale fatigue crack growth experiments, and evaluation of hydrogen permeability and embrittlement mechanisms. The laboratory is approximately 90,000 square feet with various testing capabilities and dedicated safety systems to conduct experiments in severe, hazardous, and in some instances lethal conditions. These conditions or environments can include hydrogen sulfide, hydrofluoric acid, mercury vapor, and now hydrogen.
DNV opened the Hydrogen Testing and Research Laboratory in 2021. What would you like our audience to know about it?
Yeah, our hydrogen test lab was opened in 2021 to address the need for all of this additional hydrogen testing that we've been discussing. We converted approximately 25% of our 84 load test frames and corresponding laboratory space to dedicated hydrogen and hydrogen blend testing environments. The testing currently assesses the effect of hydrogen on fracture toughness, crack growth rates, various degradation mechanisms, and general hydrogen permeation rates through the material. This is being conducted on a variety of different materials that are used in pipeline and pipeline assets. These 22 test frames have been running continuously for the last year and a half and will continue to do so for the foreseeable future.
Well, this has been great, David. Thank you so much for sharing with us today.
Thank you, Rebecca. Thank you for the opportunity.
Again, today we were joined by Dr. David Norfleet from DNV Energy Systems. To learn more about DNV and their material laboratory testing capabilities, visit dnv.com/Columbus Lab. I'm Rebecca Bickham, editor of Materials Performance Magazine. Thank you so much for watching.